Hi, and welcome to my second lecture for the Humanities Seminar Program course on horses in motion. Today I'm going to talk about the evolution of the horse from Eohippus to Equus, and this is a 55 million year journey that has led to the modern horse. So the early ancestors of the horse, or Eohippus, from about 55 million years ago, were about the size of a fox, so 2 feet long, 1 foot tall, and they lived in dense forests where they fed on relatively soft vegetation. They also had toes. So on their front feet they had 4 toes, and on their hind they had 3 toes, and these were well suited for walking on soft ground. Now, over time, the Earth's climate changed and forests shrank, grasslands expanded, and the horses evolved accordingly. So one common trend was to evolve a larger body size, and this aided in increased speed and endurance. There was also a shift to fewer toes, so this shift evolved a single hoof, which is more efficient for running. And also the horses evolved stronger teeth for grinding tough grasses. And all of this again was due to adaptation to grasslands. Now there were a few key transitional species along the way. So Mesohippus, which we see here on the left, from about 30 to 40 million years ago, were larger. They had 3 toes on each limb and more developed teeth. Merychippus, from about 17 million years ago, were the first grazing horses. The middle toe, in this case, is becoming predominant, and the other 2 toes are much reduced. And Merychippus is starting to look like the modern horse to some degree. Then Pliohippus, from about 5 million years ago, is almost modern, has a single hoof, and is a fast runner and well suited to grasslands. So this does present a simplified view of what happened, though, during the evolution of the horse. So the basic idea of how this presented again is that you have Eohippus, which is relatively small and fox-sized, again with 3 to 4 toes. And then over time, Mesohippus, Merychippus, and so forth become larger, closer to the size of the modern horse. We have this one toe that predominates and becomes a single hoof. So this would lead one to believe that this is a linear process going from Eohippus to the modern horse, but that isn't quite exactly how things happened. So this is a nice graph showing the adaptive radiation of the horse with Eohippus down here. And what you'll see is that the images that are showing vegetation, that's the diet of the horse, or the horse's ancestor. So we have mostly browsers excuse me, early on. And again, Eohippus was living in forests and eating soft vegetation. And then over time, we see the shift to mostly grasses, especially in this branch, and the horse is becoming larger. So, but the thing to note is that we are going from Eohippus to the modern horse more or less along this branch. So we see that larger size, the transition from browsing on soft vegetation to eating grasses, but there are a lot of other branches, and unfortunately those animals went extinct, but we do see on this branch, a smaller animal that's eating mostly soft vegetation or mixed. And we have another branch over here. So it's just, when we think about Eohippus evolving into the modern horse, we are focused on this one branch. But of course, the history is a lot more complicated. And over the past 20 million years, there were genera that were either browsing or grazing or mixed. There was a large diversification in body size and how the horses or the horse ancestors would forage. Okay, so let's talk about the branching of Equus. In this genus is from about 4 million years ago. It's the last surviving genus of the once highly diverse horse family Equidae. And just to go back briefly, if you review the slide from before, we see that there were the other genuses that had gone extinct. So this genus evolved in North America and then spread to Eurasia and Africa. All right, and this is a link to a video that talks about a more recent controversy where scientists have been working to bring back a wild horse from extinction and questioning if it's truly the same animal. So if you're interested, I'll leave that video for you to watch. So we have 3 major lineages of Equus: the horses, the zebras, and the donkeys. Equus ferus includes the Przewalski horse, which is the last truly wild horse, although there is some debate about whether or not they are 100% truly wild, and the domesticated horses Equus cabilis. There are the zebras that have been adapted to African grasslands, and they have distinctive striped coats for camouflage and social signaling. And then Equus africanus, donkeys and wild asses. And this also includes the onagers and kiangs. We can also look at this on a phylogenetic tree. So Equus here includes one branch for the horses, again Przewalski and cabilis. We have the zebras, and there are a few species, and then the donkeys on the 3rd branch here. Okay, so let's go back and think about the evolution and dispersal of horses and their relatives. So the origin in North America goes back about 4 million years ago. And Equus, the ancestor of modern horses, evolved in North America. There was migrations over land bridges about 3 million years ago, including the Bering Land Bridge, where horses spread from North America to Asia, and then also into South America through Panama. And once horses were in Asia, they eventually dispersed to Europe and Africa. Now, unfortunately, horses went extinct in North America about 10,000 years ago. This was likely due to climate change and human hunting. And there were no horses in North America until the Spanish reintroduction in the 1500s. So this was the return of the modern horse. And Spanish explorers brought domesticated horses back to North America. There are several points of landing, but you can see how they migrated from the Caribbean into South America, up through Mexico, and into North America. And Native American cultures quickly adopted and spread these horses across the continent. Okay, so let's flip back and think a little bit about horses and humans and their domestication. So we do have evidence of early interactions going back about 30,000 years. And the depictions of horses in Paleolithic cave paintings, including in Chauveau, France, horses are often shown in large herds in these paintings, and humans hunted the horses for meat, hide, and bones. There are some archaeological sites that suggest large-scale hunting, and there's evidence of cooperative hunting techniques, including driving the horses off cliffs. So how does the horse compare to other animals that have been domesticated? We have a little more evidence when it comes to dogs, goats, and sheep. And it's been challenging with horses because horse bones from these early archaeological sites do closely resemble those of wild horses, making it difficult to determine domestication. Also, unlike cows or dogs, the early domestic horses left fewer physical traces, and we have to rely on indirect evidence. So early horses typically weren't kept in enclosures, and again, they were similar to wild horses. And this is a nice diagram that shows when various animals were domesticated, the first being the dog, and then we have goats, cows, pigs, cats, eventually llamas, horses, perhaps about 55,000 years ago, camels, rabbits, and so forth. So this is where the horse lies in the spectrum of animals that have been domesticated. So when and where did this happen? Again, approximately 4,000 to 3,500 BCE. And the origins are thought to be on the Eurasian steppes. Horses were thought to be first domesticated by the Botai culture in present-day Kazakhstan, Ukraine, and southwest Russia. Domestic horses likely descended from wild Equus populations in this region, although there is some debate and various theories about whether domestication was a single event that then propagated or if there are multiple origins of domestication. Also, how the horses were used is debated. There are some thoughts that early domestication may have started for milk production before horses were used for riding and labor. And some of the earliest evidence for domestication comes from horse teeth showing bit wear. So these marks suggest that early humans were riding horses and using them for labor. Chemical analyses of the teeth also reveals diet shifts and possible changes due to human management. The earliest depictions with riders are from much later. On the right is painting from Egypt with the goddess on horseback. And there's also evidence from human skeletons that show wear and injuries that are often associated with horseback riding. So, using advances in DNA analysis and domestication, modern genetic research has traced domesticated horse lineages to a single origin in the Western Eurasian steppe, although again, I think there is a little bit of conflicting evidence here. And DNA studies show that ancient wild horse populations had extensive gene flow before selective breeding reduced their diversity. And selective breeding intensified certain traits like endurance, size, and temperament. All right, so this is a nice study from Nature that shows reduced genetic diversity over time. On the top right, we have a map for more than 3,000 BC, in the middle from 3 to 2,000 BC, and on the bottom, less than 2,000 BC. The pie chart colors show 6 ancestry components averaged per location. And so what to realize here, if we look at these charts more than 3000 BC, we have some variation at different locations, lots of blues and greens. Here we have some orange. And the colors are showing in brown geographic barriers. The blue regions are showing regions of migration. Okay, so some barriers that we see in the middle here, more than 3000 BC. All right, those barriers have shifted between 2 and 3000 BC. We also see some changes in these ancestry components as well, and reduced migration. But by the time we get to less than 2000 BC, we have orange being the dominant ancestry component, and lots of migration throughout Europe and Asia. So the domestication of the horse and its use through humans has completely shifted the amount of migration and reduced the genetic diversity. So I mentioned Przewalski's horse, once considered the last wild horse. It has complex domestication links, and genetic studies have shown that it may be descended from early domesticated horses rather than being entirely wild. And these findings have challenged a long-standing belief about wild horse populations, and just shows you the power of using genetic analyses and our understanding of the history of the horse. So now I want to talk a little bit about the role of domestication in human history. And it's been well established that horses have played a large role in human civilization. They have influenced transportation, warfare, agriculture, and communication. And the ability to domesticate horses and ride them has allowed for faster travel, trade expansion, and military advantages. And their impact can be seen in ancient art, mythology, and early human societies. And here is a picture of Pegasus, just to exemplify that. So this is a nice video from TED-Ed that goes into the domestication of the horse and how horses transformed warfare. So I encourage you to take a look at this video on your own time. And there is another video of Bucephalus, who was Alexander the Great's horse. I encourage you to watch this video as well. He is one of the most famous, if not the most famous horse in history. And just, another way to highlight how important horses have been in human history is that they are largely thought to be the most painted animal in history. So here are some examples: Whistlejacket, the famous painting by George Stubbs, Napoleon crossing the Alps, and a horse ridden by a thunderstorm. And paintings of horses go way back to Paleolithic cave paintings, like I mentioned before. It's been stated that probably no animal has been more admired for its sheer beauty and graceful movement than the horse. And again, they have inspired art from prehistory to modern times. And again, because of their speed, power, and companionship, they have been thought of as symbols of strength, nobility, and freedom. In ancient civilizations, Greek and Roman, and Egyptian as well, we again see the horse in tomb paintings where horses are shown pulling chariots, symbolizing power and prestige. In Greek and Roman art, we see horses frequently in battle, races, and mythology. And in the Chinese Tang Dynasty, detailed ceramic horse statues were made, again reflecting their importance to that culture. The horse appears again in medieval and Renaissance art. They were central in manuscripts and medieval tapestries, often shown in battles or royal hunts. The Renaissance also brought many detailed equestrian portraits of rulers, which again emphasized their power and status. And Leonardo da Vinci has famous studies of horses that showcase his interest in anatomy of movement. Then more recently, the Baroque and Romantic eras, horses are used for symbolism and emotion. And again, painters like George Stubbs have captured horses in dynamic motion and detail. The horse has been romanticized as a symbol of freedom, power, and untamed nature. And again, we have more equestrian portraits of rulers and military leaders that continue to be popular. In modern and contemporary art, we see impressionists like Edgar Degas depicting racehorses and jockeys. Also, Pablo Picasso's Guernica, which shows a just distressed horse among a scene of war and tragedy and violence. Contemporary artists continue to use horses as metaphors. And the horses continue to have a lasting legacy in art. Again, they're used in commercials, modern paintings, modern statues. They reflect humanity's evolving relationship with nature, power, and freedom. And, just a trip to Etsy or Amazon or eBay or your local artist store will show numerous paintings and sculptures of horses. So looking forward in the class, we will be talking about the impact of human management on horse genetics and how human interventions have shaped modern horse breeds through selective breeding. Different horses have been selected for different traits. So thoroughbreds for speed, draft horses for strength, and Arabians for endurance. And also modern domestic horses do have lower genetic diversity than their ancient wild ancestors due to this selective breeding. We will also focus on the use of math and engineering to improve the lives of horses and also people. So we'll be discussing biomechanics and motion analysis using high-speed cameras and inertial measurement units. We don't have force plates at the U of A, but I will be discussing how they've been used. In structural engineering, there have been a number of innovations in stable design, horse trailer design to improve ventilation and flooring, in addition to safety. Material science has made contributions in advanced saddle designs, protective leg and hip gear, and so on. Computational modeling has a role in predicting stress distributions on hooves, tendons, and bones, which can aid in shoeing and rehabilitation. Computational modeling can also be used to understand cardiovascular pathologies and respiratory pathologies in horses. And environmental engineering has been applied to look at efficient waste management and water purification. So as we continue to learn more, and as more scientific breakthroughs help us to revisit what we have thought we've known about horses, there's an ever-evolving story. And there are constantly new discoveries in archaeology, genetics, and ancient art that refine our understanding of domestication. And the deep bond between humans and horses remains central to many cultures worldwide. All right, and so that is it for this lecture. I will be posting more next week, so thank you very much.